simply going to type in my equation. Now, if you have any of these plots highlighted, they can't be. Things aren't going to work right if any of those are highlighted. So, if you have one that is highlighted, I want you to press your arrow button. It'll pop it up there. And then if you just press enter, it will, in my case, it highlighted it. In your case, it would unhighlight it. So I'm going to unhighlight it again, and now I'm ready to go. So make sure you don't have anything highlighted in terms of your plots. There'll be times when we want to highlight them, but not now. Okay, so now I'm going to type in my equation. This button right here, and I apologize for my big fat finger, but this equation right here is your variable button. Depending on what mode you are in, it's going to put in one of those variables. So we hope that you're in regular rectangular mode, and when you press that button, an X comes up. Did anybody press that button and something other than an X came up? Okay, good. So we're all in the right mode. Okay, then we want to raise it to the third power. We want to raise to the third power. This button right here is your exponent button. That raises the power, so we'll just press that, and then 3. So now we have x cubed. And then what's next? Plus x squared. Now, when you do x squared, you can go ahead and do this again to the second, but you do have a squared button. So I just use my squared button, since I have that button. Plus 2x.
This is 4.
Minus 3.
Mine, like, when I try to add x squared, it's like putting the...
Get them moving over.
Yeah. The newer calculators do that. You just have to hit your arrow button and that'll move it over for you. Now, I'm going to go ahead and press graph right now. I have no idea what's going to happen. But I'm going to go ahead and press graph and see what happens. Now, actually mine worked out pretty well because my objective is to know where this stuff equals 0. In other words, I want to find x values that will give me a y value of 0. So what am I looking for? Where I cross the x-axis. And I'm crossing the x-axis right there. Now, if you don't see that picture, or you just see a piece of that picture, or you see something you don't think is right, remember you can adjust your window. This is your window right here. You can adjust that. Now, mine is set up for some problem that I did before. Who knows what those numbers are? It turns out they're okay for this problem, but you need to make adjustments. So, for example, let me show you what might have happened. Let me look at what did happen first. Okay. Okay, now, suppose I press graph, and this is what came up. I don't even see anything, do you? So what does that mean? That means I'm looking at the wrong part of the picture. Here's the plane. When you set up your window, you are telling the calculator which part of the plane to look at. If you say -10 to 10 and -10 to 10, that's called the standard window, then you would be looking at this part of the plane. Now look at my window. From 10 to 20. So what am I looking at? I'm looking at this part of the plane right here, right? And that's okay, except what? The picture I need isn't in that part. So I need to make an adjustment so that I can see the part of the plane that I need to see. And there it is, there's my picture. Okay, is everybody seeing something that looks like that? Okay. Now, our job is to find that point. Now, you can eyeball it. You can say, oh, it looks like it's somewhere between 0 and 1. Maybe it's 0.9. That's not good enough. You spent a lot of money on this calculator, and it will find that point for you. So here's how this works. Go into your calc button, and that means press second trace. calc is right above it. And you will see all of these options, and these are all really important options to us. But we want this one, number 2, because x-intercepts and zeros are the same thing. So we're going to press 0. We're going to click down, press enter. Now, as soon as you do that, you should see your little cursor flashing on there somewhere. The calculator is going to ask you a question. It says, okay, Lisa, where do you want to set your left bound? Your left bound has to be set somewhere to the left of the point you're looking for. This is the point you're looking for. Is that cursor flashing to the left of the point I'm looking for? Yes. So I'm just going to press enter. It does not matter where the bounds are set as long as they are on the appropriate side. So my cursor, and you see that little arrow coming up there? That's your left bound. Now, where's your right bound? It doesn't matter, but it has to be somewhere to the right of this point. Is my cursor to the right of that point? No. So I'm going to move it. Using my arrow buttons, I'm going to move it. Is it now to the right of that point?
Yeah.
So I'll press enter. And now I have created a little space for the calculator to find the point that I want it to find. The point I want it to find is that one. It says, Lisa, where do you think that point is? Well, I don't know. I'm going to move my cursor using my arrow buttons until it's approximately on that point. Don't worry, the calculator will get it exactly on that point. You just get it close. Press enter, and it tells me that my 0 is at 0.8437, whatever. Now, if the curve had crossed the x-axis in other places, this one only crossed in one place. If it had crossed in other places, guess what we get to do? The whole process over again around the other point. So if it had crossed over here, we would start all over again with second calc, left bound, right bound, but it would be around this point, or whatever, wherever the other point was. All right, let's try one more. There was one more in the homework. Let's try it, make sure we got it. 43. Okay, now this one is a little bit tougher. Equation 43. Now, this one tells me to solve it a different way. It says use intersections. Now, I'm going to do that just so we practice it one time, but I want to emphasize that especially on your calculator, you can do it however it makes sense to you. Personally, I always find x-intercepts, okay? Because if I'm looking for an x-intercept, I know exactly what my y values on the window have to be. They just have to be small. I just have to see my x-axis. But they tell me to use intersections. If I were going to do it my way, I would take this equation, set it equal to 0, and then do exactly what we just did. That's how I would do this problem. But they're telling us to use intersections, and I want you to have some practice with that, so that's what we're going to do. So first thing we're going to do is put in 2 equations. So I press y equals. Anytime I want to put in an equation, I press y equals. I cleared out my old one. Now I'm going to put in this, just this side of the equation. To put an absolute value into your equation, press the math button. Right there. There's your math button. I think it's, yeah. Click over to number in your top menu there. Click over to here and see right there, right in option number 1 is absolute value. So press enter. And then put in what you want in the absolute value, which is 2x minus 3. And close your parentheses. So where did I get absolute value? I got it out of my math menu. Now go down, and you're going to put in a second equation. You're going to put this in as a separate equation. So that's just x squared. Now what's going to happen when I hit graph? I'm going to get two things, right? And what am I going to be looking for? Where they intersect. So I'm going to go ahead and press graph. Now I made no adjustments to my window, so I have no idea. I see a point right here. I'm a little worried up here. Do you think there might be another point up there? Yeah. It looks like there might be. So what am I going to do? Because I need to see them both. What do you think I'm going to do? I'm going to make my window bigger. And what part of my window is going to get bigger, X or Y? I can't remember what it looked like, but I think Y is what I want to make bigger. So I'm going to make Y bigger. Do I see a point of intersection here? You see one there? Do you see one right here? So there's two of them. There's 2 points of intersection. Now I'm going to find them. So I'm going to find this one first. I'm going to find that one right there first. So guess what I'm going to do? Second calc. And remember before we picked this option, what option do you think we're going to pick this time? Intersect. Yeah, you got the hang of this. So down I go to intersect. Now remember the questions that were asked before were, what's your left bound? What's your right bound? The question that's being asked now is, where do you want me to look on the first curve? Here's my cursor flashing. I need it to be on this side of the point of intersection. Does that make sense to you? It's sort of like left bound, right bound again. So I'm going to move my cursor. Okay, and press enter. And then up came my little deal. Now guess what I'm going to do? Move that cursor, press enter, and then move it so that it's about on the point of intersection. What is that point of intersection? -3, 9. Okay, now you try the next one. Now I want you to find this point of intersection right here. The calculator doesn't care how squished up everything is there, but if that's too squishy for you, change your window, open it up a little bit. The calculator will handle it just fine. But see if you can find that point of intersection now, following exactly the same steps that we just went through. So for those of you that aren't sure, second calc, down to intersect. Now, where do I need to have that cursor flashing? Probably not clear up there. I need to move it down here, right? So I'll move it down a little bit. This is not an exact science. Now I'm going to move my other one. And it looks like 1, 1 is the other point of intersection. Now that second calc menu is going to be hugely important. We've talked about finding zeros and points of intersection now. What do you think we're going to be doing here with mins and maxes? Finding the top when you have a curve that's, got a hill in it, or a valley, finding the bottom. We're going to use those buttons a lot. Okay, so we good on that? All right, I need to talk a little bit about what you're going to be doing in tonight's homework, and then we'll look at your review work that you were supposed to have done for homework. Tonight's homework is very, very simple. square roots of negative numbers, right? So, I know you have all done this, so I'm not going to waste a bunch of time, your time going back through it, because I think we need to review a little bit. But let's make sure everybody's clear on the basics. Square root of negative 4? 2i. Anytime you have the square root of the negative, step 1 is pull the negative out as an imaginary unit, as I. The square root of negative 1 is I. So if I think of that as negative 1 times 4, that's the square root of negative 1 times the square root of 4. It's I root 4, which you said was 2i. The only time this causes an issue is when we have a multiplication problem and someone says, let's take the square root of negative 8 times the square root of negative 2. And kids will say, oh, that's the square root of 16, that is 4. Wrong. I told you here, maybe I said it fast and you didn't quite catch it, but whenever we have the square root of a negative, what's the first thing we do? Take out the I. So you don't do anything here until you take out the I. So I root 8 times I root 2. So no, that's not 2i, that is I squared times the square root of 16. What's I squared? Now use your heads here, kids. I squared is not 1. I squared is negative 1. What's the square root of negative 1 times the square root of negative 1? Negative 1. When you take, think about it. What's the square root of 4 squared? 4. What does this and this do? They cancel. So what's the square root of negative 1 squared? Negative 1. I squared is negative 1. If you don't remember that, didn't learn, I squared is negative 1. So what's the actual answer to this problem? Negative 4. Negative 1 times 4, negative 4. What if we wanted to add a couple of complex numbers? How do you think we add those complex numbers? Use your common sense, don't make it hard. It's easy.
Just add the like.
You add the like terms. So in other words, you add the parts that don't have i's, so that would be 1. And then you add the parts that do have i's, so that would be negative 1. I? Yeah, negative I. Easy. How about subtraction? What if we wanted to subtract these numbers? I'll use the same two numbers. What if we wanted to subtract them?
When I type 2 plus 3x,
What do I do here? Use your head, common sense, minus 4 plus 3i?
Yeah.
So what's our answer?
Negative 7 plus 5.
Yep. Kids, this is not easy, or it's not hard. This is easy, right? What if I want to multiply them? Same two numbers, but I want to multiply them. What would I do if I wanted to multiply those guys? Foil them, bingo. So a FOIL would be negative 12 plus 9i plus 8i minus 6i squared. Now what about these? 17i. Watch this carefully. What's negative 6i squared? 6. So I got a 6 and a negative 12. There's my answer. This is plus 6. Everybody good? How about division? What do I do with that? What do I do? Someone said it. I'm going to multiply the top and the bottom by 4 plus 3i, which has a name. What do we call that? Not the reciprocal. It's called the conjugate. Be careful, what would the conjugate of negative 3 plus 2i be? Negative 3 minus 2i. Remember, when you take the conjugate, you only change this sign right here. And what's the purpose of that? Why am I doing that? Exactly. On the bottom, when I FOIL, I'm going to FOIL the top and the bottom. I'm going to do the bottom first because it's the most exciting. When I do the bottom, the i's are going to cancel out. Watch. I get 16 plus 12i minus 12i minus 9i squared. These cancel, right? And what about negative 9i squared? 9, so my denominator is just 25. We have a rule in mathematics where you're not allowed to have a radical in the bottom. Do you remember that rule? I's a radical, so you can't have any i's in the denominator. Got to get rid of them. And we get rid of them by multiplying by the conjugate. Okay, what's the top? So simplifying, we get negative I and negative 18, is that right? Yeah. Now be careful, once in a while these will reduce. If we ended up with this, that would not reduce. Do not try to cancel unless you can cancel every part. If you can cancel every part, and I mean there's a 2 here, a 2 here, a 2 here, then you can go ahead and do that. But if there is only a 2 in a couple of the pieces, don't cancel it. That does not reduce. This obviously doesn't reduce. This would reduce. Emma?
Okay, I don't understand how negative...
You need to talk louder, I can't hear you.
I don't understand how negative 9i squared is just 9.
Okay, remember, I squared is negative 1, so this is negative 9 times negative 1. Okay, a couple of new things maybe to you. We can graph complex numbers. So if we had the number 2 plus 3i, we would graph it like this. Now, that's called a vector. We graphed it as a little vector starting at the origin. And where's that point? It's not a coincidence. Over 2, up 3. Over 2, up 3. So how would I graph negative 4 plus I? Over 4, up 1, there would be that one. Now, I'm just arbitrarily going to call this number Z. Your book does this to use some special notation. So if I refer to this number as Z, so this is a picture of Z right here. This means the length of Z. Now it looks like absolute value, and it's absolute value notation, but it doesn't mean make things positive. That's not what it means. In terms of a complex number, it means what's its length. So take a look at this number right here. What's its length? It's distance from the origin. How am I going to figure that out? How am I going to figure out the length of that number?
The distance from 0, 0 to 2.
I could do the distance from 0, 0 to 2, 3. That would be one option. Anybody see another option? How about if I dropped a perpendicular here? What kind of triangle is this? Right. And how long's this side?
2.
And how long's that side?
3.
What could I do? The Pythagorean Theorem? And in fact, if I did the Pythagorean Theorem, I would have 2 squared plus 3 squared, right? next time I'm not going to draw a picture of this because the sides of the triangle are nothing more than these numbers. So if I want to know the length of this one, let me call this Z sub 1. If I want to know the length of Z sub 1, how long is this side of the triangle? Well, it's 4, right? So that'd be 16. How long is this side of the triangle? So the length of that number is root 17. I never finished this one. The length of this one is root 13.
So the length of Z would be root 13?
The length is root 13 of the original number. So this notation refers to the length of the number if you sketch it. This notation refers to the conjugate. So if you have a complex number with a bar over the top, that's read Z bar. Z bar is the conjugate of Z. If this is Z, then what would Z bar be? 2 minus 3i. What is Z sub 1 bar? If this is Z sub 1, then Z sub 1 bar would be? Perfect. Now, just one more random idea that you may have talked about, but it will show up in some of your homework. What are you going to do with I to the 78th power? Now, so far, we know I squared is what? Negative 1. What's I cubed? What's on that iPad? Blank? You're just looking at yourself or what?
It's just there.
Okay. What about I cubed? Be careful. I cubed would be I squared times I. And what's I squared? Negative 1. So what's I cubed? Negative I. Let's look at I to the 4th. That would be I squared times I squared, wouldn't it? That's 1?
Yeah.
So wait a second. Every time I have 4 i's, they just become a 1. So if I wrote out I to the 78, which I'm not going to do, but if I wrote out I to the 78, every group of 4 would just make a 1. So I'd have 1 times 1 times 1 times 1, and so on. What am I interested in? Not all these 1s, because what am I interested in? At the end, how many of them don't get circled?
Yeah.
How can I figure that out without writing them all out and circling them all? I could take 78 and divide it by 4, and I would get 19 with a remainder of 2. Now what does that 19 mean? Or 1 times 1 times 1 times 1 times 1, 19 times? That's irrelevant. What's 1 times itself 19 times? 1. Forget it. This is the important part. Because what does that tell me? That after I did my 19 circles, there would be 2 i's left over at the end? So what's the answer to this question? Negative 1. I squared. I squared. So if we have a big power of I that we have to evaluate, we are simply going to divide it by 4 and examine the remainder. It's only the remainder you care about, because everything else is just 1. Okay? All right, last night's homework was this review stuff to kind of catch everything up. So who found a question about one of the review problems? You need to tell us which page you're on, the quiz or the review sheet. So, Madeline.
quiz, like P1 through P5.
Uh-huh.
I just have a question for 5, B, and A. Like, I'm confused
For
with
5.
5, A, and B. Like, when it's negative. Like, when
Okay, we're looking on the quiz at 5A, which is negative 2 cubed.
Yeah.
Remember that the exponent goes only with the 2. It goes only with what it is attached to. So I have a negative 1 times 2 cubed. That's what this problem says. That's negative 8.
So when I do those parentheses,
And B says the whole shebang is being raised to the negative second power. So that would be 1 over 3x squared, which is 1 over 9x squared. Maggie?
number 2 on the front side of the quiz, this is all for the 3x squared minus x equals
What kind of an equation is that? It's a quadratic equation, and what do I do with quadratic equations?
you either factor for the start.
Exactly. So what's your problem? You had 3 options. No, I mean, why are you asking me to do this problem?
I don't know why, but my brain did not think to put it in the quadratic equation, so I saw that it was like 3x squared minus x equals 4, so I divided it by 3, and then I have like x squared minus x equals 4/3, and I did like x times x minus, I made it super complicated.
Okay, you must set your quadratic equations equal to 0.
Yeah.
Okay, that's gotta be step 1. Get it set equal to 0. Then if you decide to complete the square, which I never would in a zillion years in this problem, because dividing by 3 is going to fill it up with fractions. But if you're going to complete the square, then yeah, this goes back over on the other side. But for every other procedure, you were doing factoring, and you don't factor ever unless you have it set equal to 0, always. This one, I think, looks like it might factor.
It does.
So you should have gotten 4/3 and negative 1 as your answers, regardless of how you did it.
Yeah, I did.
But you take that.
Okay, who else had a question about one of the problems you had to do?
Yeah.
5A on the review.
5A on the review, we're solving an equation that's got fractions in it. So what did you do? How did you begin?
I multiplied like everything by 4, 7, and 5.
Okay, so what is that, 140? So you multiplied everything by 140, which is what 5 times 7 times 4 is. Okay, so 4 goes into 140 35 times, so you had 105. Keep an eye on my written set, I think that's right. This goes in 20 times, so minus 20x. And this goes in 28 times equals 28.
I did it last year.
So subtract 105.
So negative 20x equals, that the 105 is that 77?
Yeah.
That's a great number, negative 77. So x equals 77/20.
Number 3 on the quiz.
Uh-oh, value of the discriminant, what is the discriminant?
It's, what's inside the radical,
Which would be what?
it's, b squared minus 4ac.
Yep. So again, this is a quadratic equation, and I just told somebody that when we solve a quadratic, we do anything with a quadratic equation, what's the first thing we're gonna do with it?
You're gonna move 5x plus 1 onto.
I'm gonna get it set equal to 0, that's exactly right. So b squared minus 4ac, 33. So my discriminant's 33. And what does that tell me about my roots? The They're irrational. There are two irrational roots. How do I know they're irrational? Because 33 is not a
Perfect
square. All right. Who else?
I just like not like getting to solve it, but how do you like after you get like the complete the square you have it like
What problem are you on, Anna?
8 on the view sheet? So after you have it x squared plus 2x plus 3 equals 6, then what do you do?
First thing, I'm going to get set equal to 0. Right? That equation's backwards for me, so I'm going to turn it around. All right, so there's my equation. Now I'm going to complete the square. So what am I going to have to do to complete the square?
Divide by 2.
I'm going to divide everything by 2. Luckily, no fractions, so that's good. Okay, then what am I going to do?
Add 5 over or subtract.
Okay, then what do I do?
Take half of 2, so 1 and times it by 1. So you add 1.
Then what do I do?
Then you add it. Or
Yeah, I added 1 to both sides.
I don't know what to do now. I mean, you get negative.
What did we do that for, Ann?
Oh, quadratic. Right? Equation? Or no, like factoring, right?
This is a perfect square. That's why we call it completing a square, so that we can write this as a square. Because then I'm going to do what? Since it's a square, now I'm going to square root both sides. And I get square root of -4, which we just talked about this morning. That would be
2i.
plus or minus 2i.
Okay.
So x equals -1 plus or minus 2i. If I had done the quadratic formula on that problem, my discriminant would have come out to be negative. How do I know that? Because my roots were imaginary, right? All right, anything else on the quiz or the practice sheet?
I don't know if that's true. If this drops, do you just add them? And it's to do subtract. Are you sure? Yes.
Okay.
That's fine.
Let's look at,
Or just subtract it when it drops down.
let me just throw a couple problems up here then for practice. Got a few more minutes, so let's just see if we're ready for this thing tomorrow. Midpoint. Quickly, clock's running, midpoint. -4 plus 5 is 1 divided by 2. 1 plus 6 is 7 divided by 2. Perfect. How about this? Let's write the equation of the line. Perpendicular to 2x plus 3y equals 8 and containing -2,4. How do we do this one? And how do I find the slope of this line? Get y by itself. Just do a little arithmetic here, rearrange things. What is the slope of this line? What is the slope of the perpendicular line then? +3/2. Now the directions didn't tell you how to do this problem, so you get to pick. What are your options if you're writing the equation of a line? Slope-intercept form, y equals mx plus b, or point slope, y minus y1 equals mx minus x1. So you can do whatever you want. I, will point slope whenever I can. So I'm going to say y minus 4 equals 3/2 x plus 2. Now you don't have to do it this way, but does that make sense to you? They gave me this point. So so y minus 4 equals 3/2 x plus 3. So my answer is y equals 3/2 x plus 7. Everybody okay with that? Okay, suppose that I give you 2 points like these and say, write the equation of the circle that has that as a diameter. All right, what is your process? Okay, we got the midpoint. And so in terms of the circle, that would mean x minus 1/2 squared plus y minus 7/2 squared. We would have that much already done. Then I need this number, which will be the radius squared, right?
Yeah.
Now, you can find the distance, remember, here's the situation. Here are these 2 points, and then this one's right here, right? So you can find that distance, the distance between these 2 points, but those are fractions. So you might, in this case, want to find that distance using the whole numbers, and then just be sure to cut it in half. So, and then whatever you get, so you're going to find that distance, which would be 6 minus -4, 100, plus 16. It'd be the square root of 116. If I did my arithmetic right. Oh, no, that's not right. That's not right. That's not right. That's not right. Oh, my goodness gracious. I'm crazy. That's 81 plus 25. Is that root 106?
Yeah.
That's better. Okay, root 106. Does that break down? No. So your radius is this. So what do you put here in the box? Wait a minute, what do you put here in the box? 106 divided by 4. That square. Okay. Quiz tomorrow. Like the practice quiz on your review sheet. Be ready. No. Oh, we have a change. Before 7, because I think I have PLC. Or PLC I can set you just in the corner somewhere and have you do that Wednesday morning.
Okay.
Okay. This thing keeps running.